Your phone keeps 6 diaries about you sleep. Steps, texts, music, spending, workouts, and none of them knows the others exist. But watch midweek. Sleep dips, steps fall, the texts go quiet, all at once. That's not coincidence. Something shifted underneath, all 6, something your phone never recorded, never even had a name for, and it moved them together, each in its own language. Pulling that hidden thing back out of readouts that look nothing alike is one of the hardest problems in modern biology. It's how a genome, a batch of proteins, and a clinical chart get read as one story. Your week is that same problem, shrunk to something you can feel. That's multi-omics factor analysis. That's MOFA. Look closer at what these logs actually are. Sleep is a number of hours. It drifts up and down smoothly. Whether you worked out is a yes or a no. Texts are account 0, 3, 11. Music, money, calendar, everyone is a genuinely different kind of measurement. You couldn't stack them in one spreadsheet and take an average. They don't even share units. So how do you find one story running underneath 6 logs that don't share a language? The trick is to assume the week really is simple underneath. Picture each day as a single point. Its position set by that day's numbers 1 axis for each log. A whole week is a little cloud of those points. And here's the thing, the cloud doesn't fill the space. It hugs one direction, like beads threaded on a tilted wire. That direction is the hidden pattern. We write it as a loading, W for that view, saying how strongly the pattern pushes on each log. And a day's position along the wire is a single hidden number, the latent state, written Z, and a latent factor is just a variable we never measure directly. So a few hidden numbers rebuild every measurement. Y for view M is approximately Z times W transpose for that view, plus a little noise off the wire. Slide that one hidden number along the direction and watch every log move at once, a smooth bump in sleep, a flip switch for the gym, a jump in the count of texts. One driver, rendered in every dialect. But the logs aren't even the same kind of measurement, so each keeps its own likelihood, its own rule for what a data point looks like. Sleep hours are Gaussian, a bell curve. Worked out or not is Bernoulli, a coin flip. Text counts are Poisson, counts of events. And if a value is missing a day, the phone was off, it's simply skipped, not made up. Notice what just happened. That cold coming on state hammered your sleep and your steps, but it left your spending completely alone. A hidden state doesn't have to touch every log. Some drivers are loud in one corner of your life and silent everywhere else. So the model needs a way to decide, on its own, which logs a given state even reaches. Here's the whole grid of loadings, every hidden state, in every log. This first state, in gold, has weight in all of them. It's a shared factor, part of every channel. This second one loads on sleep and workouts, but on texts it's essentially nothing. And that's not something we told it. The model keeps a dial for each state and log, para precision, written alpha, and turning that dial up shrinks the whole loading towards 0. Its own name for this is automatic relevance determination. As alpha for a view and factor goes to infinity, that loading column collapses to 0, the state is switched off in that log. The model learns those dials from the data. It prunes the connections that don't earn their place. So what survives is a clean split, some states shared across your whole week, some private to a single log. And it goes one level finer. Even inside a log, a state does touch. Only a few features actually fire a spike hen slab prior that keeps most of them at exactly 0. Sparse on purpose. But your week isn't one uniform thing either. Your weekdays and your weekends are almost 2 different people. A social energy state that's roaring on Saturday might be flat on a Tuesday, the same driver, running at a different volume in 2 seasons of your week. Plain factor analysis can't see that split. This is exactly the gap the plus in MOFA Plus was built to close. Split the week into 2 groups, weekdays and weekends, and let the model track each state in each group separately. Take that social energy state. On weekends, its activity is high. On weekdays, it's nearly flat active in one group, switched off in the other. Here's the key move. The original MOFA put one relevance dial on the loadings, one per view, deciding which logs a factor touches. MOFA Plus keeps those and adds a second dial, this time on the factors themselves, 1 per group. The loadings stay shared, so social energy means the same thing on a weekday and a weekend, but its activity can be switched on for one group and off for the other. That second, per group dial is the entire plus. Now compare it with a state like your baseline need for sleep That one is active in both groups equally, shared straight across. So the model can finally answer the real question about any driver of your week. Is it universal? Is it specific to one log? Is it specific to one group or some combination? Structure, sorted along every axis at once. After all that fitting, here's what your phone could finally hand you. A single panel that explains your week, not the raw graphs as summary. For every metric, how much of it each hidden state was responsible for. This is the part MOFA is really for. This grid is the answer the whole method was building toward. Down the side, your hidden states. Across the top, your logs. Each square is the variance explained r squared the share of that log's ups and downs this one state accounts for. Read it straight off. This top row is bright all the way across. A state that explains a slice of every channel, a shared driver. This single bright square, lit in just one column. A state that lives in one log alone specific. Shared versus specific, not guessed measured, and read off a grid. Formally, r squared for a log and a state is 1 minus the leftover variance after that state's contribution, divided by the log's total variance. That's the payoff. Now read it honestly. First, these states are straight-line directions of shared variation. If a driver acts on your week in a curved, nonlinear way, this grid simply can't see it. Second, a bright square means two things move together. It does not mean one caused the other. It's correlation, not cause. And third, you chose how many states to look for. You named them afterward, and the fit itself, variational inference. Climbing an approximate objective settles into one nearby peak, not the single best one. A different starting point can hand you a different grid. None of these is a bug you can tune away with a better square. They're the ceiling of the whole model class, fixed before the fitting ever starts. So when do you reach for this? When you've got several very different views of the same subjects, several logs, several essays, and you want the shared structure written in plain sight, with honest error bars. That's MOFA home. And when do you not? When the real action is nonlinear, when you need to make a claim about cause, or when you've only got a single view, in which case you don't need any of this. You just need its simplest ancestor, which raises a nice question. What is this method underneath? Step back, and MOFA Plus is just one member of a very old family. Because it's Bayesian, it doesn't hand you a single answer, it returns a posterior, a spread over the hidden states and their loadings, so every factor comes with error bars. Strip it down to a single view, Gaussian noise, no sparsity, and what you're left with is ordinary principal component analysis, PCA, is this exact model with the lights off. Give each feature its own noise and its factor analysis. Line up two or more views that share the same factors, and you have canonical correlation and group factor analysis, MOFA direct parents, and push all the way out many modalities, mixed data types, groups of samples, fit by variational inference, and you land in today's world of multi-omics and multimodal models. MOFA Plus itself, Mephisto, and their cousins the Frontier, where a genomics dataset and a clinical one get read as one story. One linear latent factor engine, wearing a dozen different names. Everything we built hangs on a few threads. The hidden states, Z, running the whole week. Each log's own dialect, its loading W. The relevance dials 1 on the loadings for each view, and MOFA Plus's second 1 on the factors for each group, deciding what's shared and what's specific. The mixed likelihoods that let 6 data types share one model, and the grid of variance explained that let you read it all off. Underneath them, the one honest caveat. It's a linear lens, fit to a nearby optimum. 7 threads 1 week. So back to your phone on the nightstand, and its 6 little diaries. They looked like 6 separate stories. They were never 6 stories. They were a few hidden states, a little stress, a little rest, a little life, each one just telling the same handful of truths in its own dialect. Your week was never 6 stories. It was a few, told in 6 languages at once. That's MOFA,